Assalamu alaikum, dear students. Hope you are doing good. You are utilizing this time for your studies and other businesses. I expect that you are you are taking necessary informations from the different sources which are available on the YouTube or Google or whatever may be the site, and you are utilizing these informative things to develop yourself. In today's video lecture we will do question number 4, question number 1, 2 and 3. These are left as home assignment for you. I hope you can do it of your own. I will read the question. ABC is a trapezium in which AB parallel DC, BD is the diagonal and E is the midpoint of AD. A line is drawn through E parallel to AB, intersecting BC at F. Show that F is the midpoint of BC. We have given that ABCD is a trapezium. One second, I'm sorry. We have given that ABCD is a trapezium and AB parallel DC. BD is the diagonal, so let us draw the diagonal. BD is the diagonal. E is the midpoint of AD. This is the midpoint of ADE. Through E, a line is drawn through E parallel to AB. So a line is drawn parallel to AB. So this is line, we can extend it. It has been drawn parallel to AB, intersecting BC at F. Here it intersects BC at F. We have to prove that this F is the midpoint of BC. Very interesting question. Let us prove it. So first of all we will write given. What is the given? We have given that a trapezium ABCD. We will write a trapezium ABCD in which AB parallel DC and EF is drawn parallel to AB, where E is the midpoint of AD. To prove, we have to prove that F is midpoint of BC. This is the given, and let us prove it. So we have, let's name it here, say G. So it's a very simple proof, is very simple. So I have the unavailability of the space. Before here I request you we pause the video here to note it down. So we will write here proof in triangle. If you look in triangle DAB, in triangle DAB, E is midpoint of AD. E is midpoint of AD. Is it? E is midpoint of AD. It is given. And if E is the midpoint of AD, since EF is parallel to AB, it means EG is parallel to AB also. And EG parallel to AB. E is midpoint of AD and EG parallel to AB. How EG is parallel to AB? Because EF is parallel to AB. So when a whole line is parallel, half part of it is also parallel. So recall the converse of the midpoint theorem. Line segment to drawn from one midpoint of side of triangle parallel to the third side, parallel to another side, then it bisects the third side. E is midpoint, EG is parallel, so it must, by converse of this midpoint theorem, G is the midpoint of AB. Therefore by converse of midpoint theorem, G is midpoint of DB. G is midpoint of DB. How? by converse of what, again I will repeat it. Converse of this midpoint theorem is, if you draw the from the midpoint of any side of triangle, you draw a line parallel to the, suppose, this side. Then according to the converse of midpoint theorem, this, suppose DE you have drawn parallel to BC, and from the one midpoint of side of triangle, then according to the this converse of midpoint theorem, this DE, this third, the line which you have drawn parallel, it must bisect the third side, that is, it is the midpoint. E should be the midpoint of AC. So we have got that G is the midpoint of DB. Now have a look. We will write in triangle BCD, in triangle BCD, take a look. EF is parallel to AB. EF is parallel to AB. It means GF is parallel to AB. But AB is parallel to DC. We will write it. We will write it since, first of all, we will write now EF is parallel to AB. It means GF is parallel to AB. Now GF is parallel to AB. Why? Because when whole of the line is parallel, it means part of it is also parallel. But AB is parallel to DC. Is it? It is given. So two lines which are parallel to the same lines are parallel to each other. EF is parallel to AB, DC is parallel to AB. It means GF is parallel to DC, which implies that GF is parallel to DC. Why? By what reason? Two lines which are parallel to same lines are parallel to each other. GF is parallel to AB. GF is parallel to AB and DC is parallel to AB. It means GF should be parallel to DC. Now in triangle we will write, now in triangle DCB, GF is parallel to DC. GF is parallel to DC. Why? Because we have proved it. And G is midpoint of DB. How? G is midpoint of DB. We have also proved it above. I hope you will get it. Now again here converse of this midpoint theorem will come into play. G is midpoint of side DB. GF is parallel to DC. By the converse of the midpoint theorem, this GF must bisect the third side, that is F should be the midpoint of BC. It by converse of, we will write it here, therefore by converse of midpoint theorem, F is midpoint of BC. This was all about this question. How this is midpoint? Again, you have to draw the line segment from one midpoint of side, and it must be parallel to another side. Then according to the converse of midpoint theorem, it bisects the third side. Bisect means it is the point where it intersects the another side. That point must be the midpoint of that side. So this was all about this today's question. I hope you will get it. Still find any difficulty in understanding it, please let me know that. Thank you, class.